Okay, so in this long video, we're going to talk about conics, parabolas, circles, ellipses, and hyperbolas. We've touched upon these graphs before, but now we're going to take it a step further. So this family of graphs are called conics. So hopefully by now, you've kind of been able to identify the graphs based on the form of the equation. This first one, in which either only x squared or y squared, only one of them is squared, is a parabola. Then we have a circle in the form of x squared plus y squared equals r squared. We have an ellipse, and the key point to an ellipse was having that plus sign in the middle, and it had to equal 1. And then the last one, when there was a minus sign in the middle and it equaled 1, that was a hyperbola. So these are the four main graphs for the conics family. So now, why do we call them conics? They have this special name for their family called conics. So why are they called conics? Well, that comes from the study of a three-dimensional cone. So here I've drawn some three-dimensional cones on my paper here. And by making cuts, we're going to make some graphs. So imagine cutting a cone in half. A nice even cut parallel to the base. If you cut it in half and look at the cross section, what would the cross section look like? The cross section on that 3D cone would look like a circle. It's kind of hard to visualize it on paper, but imagine holding a cone in your hand, 3D. You make a cut in half. You look at the cross section, and you're looking at a circle. Imagine on another cone you make a slanted cut, a diagonal cut, and you look at the cross section of what you just cut, and it would be a circle, or an ellipse. It would have more of an oval look to it. It wouldn't be circular. It'd be an ellipse. On my third cone here, I'm going to make another slanted cut, but I'm not going to go through the other side. I'm going to make a cut that goes through the base. Well, if we look at that cross section of what was left over, we'd be staring at a parabola, right? That slanted cut through the base would leave us with a parabola. So, all these cuts through all these cones are yielding us these special graphs. So that's why we call them conics. So the last one is the hyperbola. Can you imagine how we can make a hyperbola with a cone? Kind of tricky. The cut we would need to make is actually through two cones. We're going to get two cones, and we're going to place them in this kind of hourglass shape. And if I make a cut vertically through both of these cones and look at the cross section, that's how I'm going to get my hyperbola. So I needed two cones. I needed a cut through two cones to create this hyperbola shape. Alright, so that's where this conic family name comes from. The idea that all these graphs can be made, through cuts of cones. It's the conic family of graphs. Cool. So we studied all these before. We did examples of all these graphs in all the future videos, or the previous videos. But what was kind of easy about all the graphs we did previously, and based on how they're written in this form, they all had a center at 0, 0. And I use the word center kind of loosely because parabolas don't really have centers. Parabolas have, vertices, a vertex. But for all these graphs, the center, the vertex, they were all stationed at 0, 0. So that's what kind of made them easier to graph, easier to work with before. Now, in this lesson, we're going to take it a step further. We're going to have centers or vertices not at 0, 0. So that's going to change the form of these equations. So to include a center or a vertex, we're going to use h and k. So in this parabola form, my vertex is at h, k. Now you still got to be familiar with the previous forms and the characteristics of the previous forms. When x was squared, how did that parabola look? It was either opening up or opening down, right? So you still got to remember those characteristics. To get our focus, we still use the p-value. And since the graph is either opening up or opening down, that p-value is going to be a vertical movement. It's going to be tacked onto the k-value. Right? Can you imagine in your heads this parabola opening up? Can you look at where the vertex is in your head? That focus is above the vertex. So that's going to require you to add p to the k-value. Likewise, the directrix is below the vertex. And how far below the vertex do you go? You go a distance of p. So that directrix equation is going to have an equation of y equals k minus p. Now, what happens if the equation of the parabola has y squared? Well, still got to know what that means. If y is squared, that means we're either opening left or right. Vertex is still going to be at h, k now. And if we're opening left or opening right, the focus is either going to be left or right of the vertex. So to make that movement, to go from the vertex to the focus, we got to go a p distance added on to h. That's why my focus is h plus p, k. To get that directrix, we got to go a p distance left or right of the vertex. So that's why my directrix was x equals h minus p. So let's do an example. With all that new notes, it looks like a lot of stuff. Let's just go through an example here. X minus 2 squared equals 12 y plus 1. So from this, we got to get the vertex first. And remember, with these coordinates, they kind of take the opposite sign of what was in the equation. So the coordinate of my vertex is positive 2, negative 1. So let's start with that vertex. Positive 2, negative 1. I know that since x is being squared, my parabola is either opening up or opening down. And remember, to know whether it's opening up, opening down, that requires me to know what P is. Well, in this case, 4P equals 12. So P equals 3, positive 3. So that means my parabola is opening up. All that previous study we had of the parabola, is still important. Because P is positive, we know it opens up. And again, what I was getting at earlier, if my parabola opens up, the focus is going to be sitting above the vertex, right? The focus will be above the vertex. So, the movement, if we're above the vertex, that the movement is going to be in the y coordinate. So that P value, I'm going to add onto the y coordinate of my vertex. It's going to be h comma k plus P. So my focus is going to be 2 comma negative 1 plus 3. So 2 comma 2. That's the location of my focus. For my directrix is sitting below the vertex. How much below the vertex? Well, a P distance below the vertex. So if my vertex has a y value of negative 1, and if my P is 3, well, that directrix is going to have an equation of y equals negative 4. I'm 3 units below the vertex because P was 3. So now it's just a matter of sketching in my parabola. Remember that each point is equal distant from the focus and directrix. Try to eyeball it in. And to see if you kind of did a good job sketching it in, maybe pick a few points. I'm going to pick a point on my parabola, and I'm going to show that it is equal distance from the directrix and the focus. Here's another point on my parabola. Equal distance from the directrix and the focus. Alright, so that's, we've graphed parabolas before when they were located at, when the vertex was located at 0, 0. We did it before. There's no difference here. It's just that it's a little bit trickier when the vertex is located somewhere else. Alright, so there's my finished parabola. Okay, we're going to go through all 4 conics today. Probably the easiest one of them all is the circle. Circle is just your basic shape. So if our center is not at 0, 0, our center is at h comma k, and our equation looks like this, but our radius is still r. So really it's just a matter of, can you draw a circle? Can you make the center at h comma k? And can you apply a radius of r? It's really that simple. So here's my example. X plus 3 squared plus y minus 2 squared equals 9. So where is that center? Remember that with these conics, the center, the coordinate takes the opposite sign as what's in the equation. So my center is at negative 3 comma 2, and my radius is 3. So can you draw me a circle with a center at negative 3 comma 2 and a radius at 3, or a radius of 3? That should be pretty straightforward. To make this look pretty good, let's just start with our center. Put a nice point at the center, -3, 2. And what I would do is I would just go 3 units north, south, east, west. That's pretty much as simple as you can make it. So just go north, south, east, west, 3 units from the center. That'll be 4 points on your circle. So from that point, just, complete your circle. Keep your hand nice and steady. And make your nice circle. So that's all there is to it for the circle. I'm going to label my center C, -3, 2. And I'm done. Alright, next is the ellipse. The ellipse is probably next easiest after the circle. In large part because, the ellipse resembles a circle, right? It's an oval, which is kind of an oblong circle. So if this is the form of your ellipse, your center is at h, k again. And just like we graphed them before, we're going to be concerned with A and B. A is how wide the ellipse is. B is how tall the ellipse is. But same rules apply. So we want A to be greater than B, greater than 0. If a squared is under x, the ellipse is wider. It's longer left and right than it is up and down. If a squared is under y, then the ellipse is taller. It's longer vertically than it is horizontally. So here's an example. X minus 2 squared all over 4 plus y minus 3 squared all over 16 equals 1. Remember that with ellipses has to equal 1 at the end. My center is going to be at 2, 3. A squared, A is the bigger number, so A squared is 16. A is 4. B squared is 4, so B is 2. And because A squared is under Y, again, that makes this ellipse longer in the Y direction. So, like our circle, let's start with the center. Let's start with the center, and then we can apply our A and B values from there. So I'm going to start at 2, 3. A was under Y, so A is going to be a vertical distance. So from that center, I'm going to go 4 units up and 4 units down. Now I'm going to apply my B value. B was 2, so I'm going to go 2 units left and 2 units right of the center. Alright, so now it's just a matter of kind of connecting these dots and making my ellipse. And let's try to make our ellipse more oval shaped. I think I saw some guys making it more rigid, like a diamond. It's not a diamond. It has, curvature to it. So make your ellipse curved. I'm going to label my center 2, 3. And there still are foci for this ellipse. So let's try to figure out where those foci are. To get that, we're still going to need C. So remember how to get C from before. C is the square root of a squared plus b squared, a squared minus b squared. So C is the square root of 12, which is about 3.46. And remember that C value is a distance from the center. And the foci go on the longer side. So the foci are going to be above and below the center. Since my ellipse is, longer in the vertical direction, my foci are going to be above and below the center. So I'm going to be basically affecting the y coordinate, right? If a point is above or below a point, well, what's different? It's the y coordinate. So my foci are going to be at 2, 3 plus or minus 3.46. So where is that? It's at 2, 6.46 and 2, negative 0.46. So you see how it's the y coordinate that's changed. X hasn't. These 3 points, the foci, the center, they're all above each other. And that all had to do with the graph being longer in the vertical direction. Alright, it just takes practice with these. The more of these you do, the comfortable you get, the better you know where foci are, where centers are. When you get more comfortable with that, it becomes more natural. Okay, and the last one we got to go over is hyperbolas. They're going to look, at least in the form of the equation, they're going to look like ellipses. We know that the graphs don't look alike, right? But the equations themselves will look very similar. It's just that minus sign that's in the middle, not the plus. Alright, so my center is at h, k. We're going to want to start there, and we're going to build our rectangle from here. When we graphed hyperbolas previously, we built that rectangle and kind of started with the rectangle, so let's do that again. After we get our center identified, let's build the rectangle. So for my example, we'll do x plus 2 squared over 9 minus y minus 2 squared over 1 equals 1. So my center is at negative 2, 2. I know from previous graphs of hyperbola, when x squared is first, these hyperbolas open left and right. So keep that in your mind. A squared comes first. A squared equals 9, so a is 3. And b squared equals 1, so b is 1. And it's those a and b values that help me to construct my rectangle, right? So setting up my axes here, first thing I'm going to graph is my center at -2, 2. And let's build this rectangle. So remember, A is 3, and since it's under the X, that's going to be a horizontal movement of 3. So I'm going to go 3 left and 3 right from my center. B is 1, so I'm going to go 1 unit above and 1 unit below my center, and that lets me construct this rectangle. So these diagonals through the rectangle are our asymptotes. Our hyperbola is not going to touch those asymptotes. And remember, I mentioned a moment ago that because x squared is first, that means that we're opening left and right. So that means my two vertices are left and right of the center. So if my vertices are left and right of the center, what coordinate is going to be affected? It's going to be the x coordinate, right? So if my center is at h comma k, my vertices are going to be at h plus a comma k and h minus a comma k, right? A units left and right of the center. Well, my center is -2, 2, and my a value is 3. So I got one vertex at 1, 2, and my other vertex at -5, 2. Last thing I want to identify is my foci. So again, I'm going to need to know what c squared is, or what c is. With hyperbolas, c squared equals a squared plus b squared. So c squared equals 10. So c is about 3.16. Sorry, I skipped ahead a little bit here with my video, but same thing with the foci as with the vertices. I had to adjust the x coordinate of my center. So from my center, I added and subtracted my c value, which was 3.16, and that's how I got my two foci. Sketch my graph, and my graph, approaching those asymptotes, and you're done. Alright, so I know we got a long video here, but I got a few more examples for you that will help really solidify these concepts. So I want to write equations of these graphs. So I want to write the equation of the conic. A circle with center 2, -5 and radius 5. So this one's probably the easiest. Just write in with that center. And remember, as you write the equation, the sign in the equation is the opposite as the coordinate. So my answer, the equation is x minus 2 squared plus y plus 5 squared equals 25. Again, circle is probably the easiest conic to work with. Okay, here I want the equation of a parabola with focus at 3, 5 and directrix at x equals -1. So to really see what's going on here, let's sketch in what we know. So here's my directrix, a vertical line through x equals -1. And here is my focus at 3, 5. So this little sketch is really going to help us make sense of what's going on. First of all, you should be able to tell which way this parabola is opening. With a vertical directrix and a focus to the right of it, this parabola is opening to the right. Can you see that? Not only that, but the vertex is going to be halfway in between the directrix and focus. So let's look at those x values. The directrix is -1. The focus is 3. So what's halfway in between -1 and 3? Well, that value is 2. I'm sorry, 1. 2 units left or right of 1, but the middle of -1 and 3 is 1. So that's going to be the x-coordinate of my vertex. So I now know my vertex is at 1, 5. Not only that, but I know my p-value, right? How much do we go left or right of the vertex to get the directrix and focus? Well, we go 2 units. So that gives me my p-value. My p-value is 2. And like I mentioned a moment ago, we're opening right. So anytime you open right, your y value is being squared. So I got y minus 5 squared. The minus 5 comes from my vertex value. If p is 2, then 4p is 8. And the last part is x minus 1. Again, having to do with the fact that my vertex was 1, 5. Okay, we got another one here, hyperbola. So let's try a hyperbola here. I want hyperbola with vertices 5, 0, 5, -4. And foci 5, 2, 5, -6. Well, again, sketching it is going to help you figure things out. We can see that the vertices are above each other, right? So this graph opens up and down. And we know what that means in terms of the equation. When it opens up and down, y squared is first. So here I'm just kind of giving myself the construct of the equation. I let myself some space in the parentheses for the center. So where is the center? Well, it's halfway in between the 2 vertices, right? This sketch helps me see that. So halfway in between those 2 points is 5, -2. So that's my center. So let's fill in these parentheses. I got y plus 2 and I got x minus 5 because the coordinate of my center was 5, -2. So now I need to know what A and B are. Well, A we know is the distance from the center to the vertex. And that distance is 2. So we know what a squared is. It's 4. And that's going to go under y squared. With hyperbolas, a squared is always first. To get b squared, it's a little bit trickier. We're going to want to know what c is first. I mean, we can get c from the foci. We know that the foci are a c distance from the center. So how far away is the foci from the center? That's going to give us c. Well, based on this picture, based on the information given, we can see that c is 4. So c squared is 16. So now with c squared and a squared, we can find what b is, right? Because we have this equation for hyperbolas, c squared equals a squared plus b squared. So c squared equals 4 plus b squared. So b squared is 12. So that's going to enable us to fill in what b squared is. So there is my final equation. You know, it's a lot to consume. Just trying to go over these examples with you. It just takes practice. I would suggest just go back over your previous notes on when the center was at 0, 0. Familiarize yourself with those characteristics of the foci, the vertices, and try to apply them to this new scenario in which your center is going to be a little bit off. All right, this takes practice. Let's give it a shot.